Hi, welcome to toddfun.com, where I do whatever I think is fun. Today it's going to be looking at this little Candelabra LED powered light. It's dead. It lasted about a week. We thought it would be a pretty good idea if we took our 120 volt incandescent candelabra lights and replaced them with these LEDs. But we wisely chose to do just one first, just to see how it would work and if it would, be decent lighting and bright enough. And it was quite bright. It was decent enough. It was a decent substitution, lighting-wise. This LED, it's just a whole bunch of white LEDs inside there. But no, it didn't last. Maybe a week or two. It wasn't long, and it just stopped. Now, it's interesting that it's shaped like a light bulb still, and there's no point in it, of course. The incandescent light bulbs need a vacuum for the tungsten filament to exist in, so it doesn't get around oxygen. There is another type of gas in there, I believe, maybe an argon or something, that would normally be used in a filament style light bulb so that the tungsten can, it actually boils off when it first starts up, and then when it comes to the temperature, that little whiff of gas inside allows it to redeposit back on the tungsten filament, so your filament lasts longer. Standard light bulb technology, but no point in having the bulb here at all. I mean, I'm surprised they did that, other than they just wanted the look of a candelabra light bulb. So there you go. We're still stuck with the glass and everything, though there's no functionality for it other than looks now. So we'll break this open and we'll see all those little LEDs inside and see if we can figure out, maybe see what it works on. 110 goes in and all these LEDs light up, so something went wrong. So let's bust it open. Okay, we'll ever so gently get it open. There we go. There. And let's get into it further. Seems to be potted quite a bit in there. Bit of a wire coming out to the bottom, of course. If I can yank that out. You can see the circuits packed in there. If I can get it out in one piece, I don't know. I see a bit of a circuit board down in there. See if I can get it out. And then there's another wire here. That would be the neutral. Right there. There. Let's take it over to the bench and take a better look at it. Okay, we'll take a good look at the insides. There's the stack of LEDs. There's 28 of them, and they're all just on this one little PCB board, circular mounted. Look at how horrible that soldering is in there. One wire coming there, and then the other wire comes out there, and so those two wires are for going across. And this is like some sort of a little shield piece, or a little piece of plastic. I don't think it's mica, I think it's just plastic covered paper to shield those points from these points. This is the main circuit here. We have the neutral over here, it went to the case, and then this is the center tap, which would have been the hot side. Everything is encased inside of here, which will have to do the conversion down to run these LEDs. This shrink wrap is on here, I guess to keep it away from the edges of the can. And you can see over here the shrink wrap didn't move when I took it off, and this is exposed a little bit on the side here. It's a bit sticking out. It's no shrink wrap over it. Maybe that caused my problem. Maybe it just touched across there and caused a problem. Because this is what goes up, this wire here goes up to the first connection on this stack of LEDs. So let's cut that off. Okay, and there. Take a good look at that. You got a couple capacitors. I would say, because this is the ground neutral, and then it goes through whatever this is. If you get real close up, you might see it. And I'm going to try and read it too with my eye. I'm going to say it says plus and minus on it, and it says MB6S. Not sure what that would be. And then this large capacitor, 240 volts, and look how horrible that soldering is. Look at that glob of solder, and even that little surface mount. Looks like a little surface mount resistor. Just a big old glob of solder on there. And I think a 6-year-old, I know a 6-year-old could solder better than that. That's what's inside these lights. That is the worst soldering I have ever seen. And then we have another capacitor around the bottom. It's kind of hugging a diode too. There's a diode right there. So obviously it's basically doing a bit of a rectifying, half-wave rectification, I would say. And I'd have to look up this chip in this resistor. But as long as the current is really low relative for this pack of LEDs, it should be fine. I'm going to see if what it takes to light these guys up. Well, if I can keep this in focus, I'd like to point at that right there. That leg right there off of that little chip. It doesn't even have any copper under it, let alone any solder. It's like when they made the little PCB board, they etched away all the copper plates. So the solder, of course, didn't stick to nothing. There's just a hint of copper on the one side. And maybe that's what got it to pass quality assurance. I wouldn't call this anything quality. Yeah, I'd have to say that's a good chance that that's a culprit too. There's just the poor quality. I mean, what's the point of even making these if you're going to make such poor quality? Just horrendous. I'm going to see if I can hook this up to my transformer and see if it'll actually light. Okay, we have this hooked up to my isolation transformer, just as if it were hooked up to 110 volts. So I'm going to turn on my isolation transformer, and this bulb didn't work when I took it apart, so I don't have any good hope for it now. Oh, look at that, now it works. Can you believe that? It was not working when I took it out. So maybe it was just that little bit that didn't have any shrink wrap on it was shorting out right before that one wire, this one corner was coming up to these LEDs. So there you go. That as bodgy as that is for soldering, that is actually a working circuit still. I'm gonna see if there's a lot of standoffs on here, so none of these can short out. That's a real interesting design, the way they stacked them essentially to get them a little closer together. I wonder if it gets warm at all. No, it's no temperature at all. I don't necessarily have to do anything to make this work. What would be interesting to do is, because this is so amazingly bright, really, I don't know if you could see, if I turn the lights off it would get pretty dim. It would be pretty bright. It's as good as a 60, or I don't know, maybe I'd say 40 watt bulb maybe. But it would make a good headlight for a bicycle. So I'm going to see, because it's no good anymore for 110 device, I'm going to go ahead and chop this and see if I can power it with DC and decide exactly how much current I would have to provide this thing in order to use it for, say, a bicycle headlamp. Okay, I looked up that chip, the MB6S. It's made by several companies. One would be Fairchild, and it is a surface mount bridge rectifier. It is just a little tiny bridge rectifier rated for 1/2 amp. And you can see that leg there. I just barely touched that with a screwdriver and it lifted right up. And if I turn it ever so slowly, you'll see that there's just no copper there. There's no foil. Maybe a little nip. I'll check to see if it'll work like this. Okay, I'm testing with that little leg lifted. Yeah. With that leg lifted, it doesn't come on. And that leg is just barely attached. I'm going to solder it down good. Yeah, now it's bridged across real good to that 470 surface mount. So we should have a good connection. Let's try it now. Okay, turning it on now. Yeah, it works now. Okay, let's take some measurements. I want to see what type of voltage it has. And maybe even an oscilloscope trace going, seeing how clean it is for signal. We'll start off by probing with the Fluke multimeter. Rather than trying to probe it while the circuit's flopping around, I just clipped onto it and then jacked into my oscilloscope, my Fluke. So we'll power that on, and we'll first check to see AC. And a little bit, maybe 8 volts AC is getting to the LEDs. I'm actually probing right where they go into the LEDs. The DC voltage is 81 volts DC. So it's 81 volts DC with riding on with a little bit of a ripple, like an 8-volt ripple. That's pretty high. I'm surprised. I was expecting maybe a little bit less. Well, let's see what that looks like on the scope. Okay, we got that same test point right before the LEDs, essentially the voltage conditioning going to those pack LEDs. But I got the oscilloscope this time, so we'll see a little bit there. Let's turn it on. So now we got 50 volts. If I can zoom in on the screen here a little better, I can bring up measurements and it'll do that for us. So we'll see peak is 96, min is 70, peak to peak is about 25 volts, like I was saying. Frequency is about 120, and the mean is 81. So that's what's powering those LEDs. Not too terribly bad, I guess. Let's clip a wire and see what kind of current it's drawing in this condition. Okay, we got the Fluke set up to get ready to measure current. I still got it hooked up to my isolation transformer, but I'm coming out of my isolation transformer into the amp range of my Fluke, back out, and then into this rectifying circuit that powers the LEDs, and then back to ground or neutral. So this will be an in-series current measurement. So let's go over to, let's start off with amps. We're on AC because this will be AC in this part of the circuit. So we'll go ahead and read straight on amps AC. I'll flip on my isolation transformer. And I would say we're reading about 12 milliamps AC. And that's right off of the line, basically right from the power lines. And at 120, at this point we're at 120 volts. let's take a little bit more accurate measurement. Because that's under the 400 milliamps of my more accurate range, I can go ahead and just pull out of there and go into my 400 milliamp range, and we just get a more accurate reading. We get 13.46 milliamps AC. We know that we were doing 120 volts, and we got 13 point some odd amps or milliamps, so we got 0.013, and it was roughly about 4.8, and that's how many amps it was, about 13.4 milliamps. And you basically just, for power, you just take voltage times current, and that was the 120 volts RMS, and that's the AC current that we had, so we simply times it, and we get 1.6 watts. So this little light bulb, it outputs about the same as a 40 watt light bulb, but it only uses 1.6. And I've looked it up on the internet. They don't sell this anymore anywhere. I think we paid like $12–15 for it when we got it, and it only lasted like a couple weeks. So I can't find them at Home Depot or Lowe's or anything. So they're being replaced by probably better, certainly better made stuff. This is made by Fiat, I guess. They make some pretty bad crap, I guess. And it was rated at 1.2 watts, so it's definitely, you know, doing okay for its rating. And certainly the light output is more than nice enough for, if you got, we got about a half dozen of these as candelabra lights in a dining area, and a half a dozen of these really does light the area up nice, and you'd only be using, you know, 12 watts for all of them, you know. Okay, I've cut this wire going into the LEDs, and so now I'm going to do an in-series current measurement for just the LEDs themselves. So I'll clip to either side of the wire that I snipped. Now that has to go through the fluke, so let's power it up, and we're going to turn the meter to milliamps. Let's switch this to DC on this. About 9 milliamps DC. I suppose that's to be expected because it's mostly a DC signal. It's with a big ripple. So let's assume that that's a straight-on DC voltage. Just don't worry about the ripple, though there's a pretty amazing ripple on there, a 25 volt ripple. And we're running about 9.5 milliamps. That's 0.0095. That's the milliamps in amps. Multiply that. So the LEDs themselves are using about 0.8 watts. So 9 to 10 milliamps to run all of these lights. 9 to 10 milliamps. Let's just say 10 milliamps to run the light bulbs. And that comes out to less than a watt for the light bulbs, 0.8 watts. So we're losing about, oh well, watts wise, we're losing about a full watt in the rectifying circuit. But then I'm not qualifying that giant ripple either. So really, that's not perfect math at all. So okay, well that was interesting. We know more about what this is. I think this blows my idea of using this as a headlight for my bicycle, because I don't think I'm going to be able to easily produce the 84 volts that this probably mostly in series light bulb array needs. That would be silliness to try that. There would be other ways of doing a lighting solution. I was just thinking with such low wattage, it'd be easy to produce the energy, but I don't know, getting it over to a DC signal at 84 volts to drive this might be a bit much. But let's see what this thing does when we hook it up to just, my straight on power supply. Let's see what a straight on 30 volts does. Okay, I guess this will be about the last test of this thing. I'm going to see if I can drive it. I think this will go up to 30 volts. I could probably chain these together, series these up and double my voltage. but let's just start with 30 here. And I'm just going to start ramping it up and see if we get any light coming out of this thing. It's coming up to my full 30 volts. Full on 30 volts, and I don't even see any light coming out of there at all yet. Well, let's switch this thing to a series. So rather than having, we don't want a parallel, because parallel would be for increased current. We want a series for increased voltage. So we'll come from this side, and then we'll go series. That's almost max. That's 60 on both. There's about 60 volts across there. Look into here and see if we got. I should have 60 volts across here. Yeah, 63 volts. So the meter, or the power supply, is working in series. I do have 63 volts, and 63 volts is not enough to light those bulbs. They actually have to be pounding around 80 some volts, and I do not have any way of producing any more than 63 volts DC. I'm surprised. I would have thought they would have lit. Just really faintly or something maybe. So it's not that. You know, it's not like it's hitting current limit or anything like that. It just literally, it's just not gonna run. Unless it gets more volts. Yeah, that voltage is there. Well, wait a minute now. What happened? I saw it light, didn't you? Well, how come it lit? Maybe I just managed to touch across a few. Maybe I was what caused it to light was maybe I just sort of touched it someplace where it had less current as necessary. Yeah, there we go. So basically, that's what happened. As I touched a spot that wasn't it wasn't every single one of the bulbs. If I go down even one bulb, I'm not lighting them all with 60 watt 60. I'm like shorting out half of the bulbs, and then 60 volts is good enough. Oh, I fried that one. A little too much for that bulb. I can smell it. Got a little too warm on one of them. Now we're dead. Yeah, I wasn't going to get to produce that much voltage anyway. Well, you can see the ones that burned out are black. I don't know if that shows up in the camera. The ones that are still nice and yellow didn't burn out. The ones that are dead are black. That's funny. They popped. I popped it! Too bad Photo Induction doesn't still have a channel. I loved his stuff. Turn these back down. And turn off the series button. That's a nice power supply. Series for more voltage, parallel for more current. Gotta love that guy. Well, there we go. That's what's inside this particular style of LED candelabra light bulb. Small little circuit, little surface mount bridge rectifier, smoothing cap, pushes out about 84 volts mean and peaks at about 100 volts and drops at about 75 or so volts. Pretty bad ripple, but it's close enough DC to run this big old clump of LEDs. And there's about 28 of them, I said. And you got to have more than 60 volts to run them. So that's why it's up at 80 some volts. So I don't see these on the market anymore. They're going to where you don't have to solder in almost 30 LEDs to make a little 40 watt equivalent light bulb. They're gotten better, of course, already, and that's going to get even more and more better than this. In fact, this is I've seen these on eBay already for $15 a piece. I don't know why you'd want to buy one. They're made such crap. So that's it. Just a look inside this little candelabra LED light bulb. So hope it was interesting a little bit. Thanks for joining.